Hello, welcome. Today let's try to solve another Leetcode problem, 316. Remove duplicate letters. And for this problem, we are giving an input. So this is just lowercase letters. As you can see, it is BC, ABC, and the output is ABC. And we need to remove some duplicate letters. And we need to keep the smallest lexicographical order among all possible results. So the smallest order for the unique character, that is ABC. For example, if it is BCA, it is bigger than ABC. We just need to find the smallest. So for this kind of question, I call it with the dictionary sequence monotonic stack. We're gonna use this kind of idea and solve the problem. And this problem is the same as 1081. As you can see from here, it's exactly the same. The only difference is the testing case. So here the length of the string is 1000, and for 316, this length of the string is 10 to the power of 4. So this is the only difference. So I'm gonna talk about two problems together. I'm gonna solve this problem 316 first. After that, I copy the code to test if it works. Now, let's try to understand the problem. Let me first go to the whiteboard to explain the example. So for example, we have a sequence like B, C, ABC in the example. Normally for such kind of a problem, it's really difficult to solve by brute force. Because for using the brute force, we have to check all the cases, and it's really difficult. But the easiest way to solve it is by using the monotonic stack idea. Actually, it is a greedy idea. First of all, for each of the characters, it must appear one time. How can we keep it? We can use a dictionary, or we can use a counter. So I'm gonna use a counter to store the frequency of each character. So for example, so for A, it will appear one time, and for B, it will appear 2 times, and for C, it will appear 2 times. So this is the counter, and the final result. So for each of the character, it must appear only one time. So this means while we are using the monotonic stack, we need to keep each of the characters inside the stack. It must appear one time. So this is this question is actually the same as let me go back. I didn't put it here, but let me go back. I think this question is the same as the sequence of the digits. So there are some digits. So let me explain. The smallest order of the digits with the remove of k times. For example, we have 1, 2, 2, 3. We need to remove one character. Only one time. We can remove k times. So this k is equal to 1. We can remove one character. We need to find the smallest sequence for the string. So for this example, we can remove this 3 directly because 1 to 2 is the smallest. So this kind of question is the same because we need to find the smallest sequence. Actually, this is ABC. So we can use monotonic stack to check. First of all, we're gonna prepare a dictionary as a counter. We're gonna count the frequency of each of the character. If the frequency for each of the character, if it is more than 0, so it means from the beginning inside of the stack, we can pop it out if we need to. But how can we check if we need to pop it out? So we're gonna check the sequence. So for example, so for the first character, this is B. We can put it inside of the stack because the stack is empty. Now we're gonna put a character C inside of the stack because the C is bigger than B, so the sequence is okay. As you can see, we're gonna keep a monotonic increasing stack. So for the next character, we're gonna put A inside. Now, if we were to put A inside, we might want to pop out this C and B, but we need to check if we can pop it out if we can pop out this C or this B. But how can we check? So this is why we're gonna use this counter. If we put B inside, so for the counter, B would be 2 minus 1, so the result will be 1. It means we still have 1B. Yeah. And then we're gonna put C inside, so the counter will be 2 minus 1. It means we still have 1C. Now we're gonna put A inside the stack. Yeah. If we put A inside the stack, because A is smaller than C, yeah, for the greedy idea, we're gonna pop out this C inside the stack. We need to check if we can pop it out or not. Now, how many times of C left? There is still a C left. It means from after this A, there is still a C left, one C left. I don't know where it is, but I'm sure there's one C left. So this means I can pop this C outside of the stack. Yeah. If I pop it out, I'm gonna continue to pop out the next one if it is possible to pop out. Yeah, so B is bigger than A. It means A is smaller than B. I'm gonna check if I can pop B out or not. Yeah, because if I pop C out, C must after A. Yeah, and AC must be smaller than CA. If I pop B out, so B must after A. So AB must be smaller than BA. So this is the idea why we can use monotonic increasing stack to solve it. So B, how many times? Oh, there's one time. It means there's still one B left. So this means we can pop B out. Now in our stack, that is 1A. Yeah, so it means we've finished. Now we're gonna check the next character. We're gonna check this B. Can we put B inside? Yes, it is monotonic increasing, so we can put B inside. Yeah, but after that, the B should be minus 1. This means B has already consumed. Yeah, I forgot to minus A, because if I put A inside, it should also minus 1. This means A is also 0. Yeah. Now I'm gonna put C inside the stack. If I put C inside, this is C is also minus 1, so it is 0. So this is the final result. So inside the stack, it is ABC, so we're gonna just return the joy of this stack. So it is the string with A, B, C, and this is the idea to solve such problem. Because we're gonna have a sequence and we're gonna use a monotonic stack to keep the sequence. But while using the monotonic stack, we need to check the frequency, check the counters, how many A's left, B's left, C left. Then we're gonna have a decision to decide if we can pop C out or not. Yeah. So for example, if we only have BCA, yeah. So first of all, we're gonna put B inside the stack. Now, for this B, it's gonna become 0, because from beginning it is 1. If I put B inside, it is 0. Now I will put C inside, and then I'm gonna put A inside. If I were to put A inside, I have to check, do I need to pop out this C? Because C is 0, I don't need to pop it out, because there's no C left. Yeah. If I were to have a smaller sequence, there must be a character C left. C is at the right side of A, but there's no C left. It means I cannot do anything. I will just keep this stack. So the final result would still be the BCA. Yeah. Now let me go to the code editor to finish the coding. Yeah, if you understand the whole process, I think the coding should be much easier. As I explained, I'm gonna prepare a counter and a stack. So for the stack and counter, yeah, it is I'm gonna call it a remain. So remain, it means how many characters left for the counter, and the stack would be empty. And then I'm gonna count the string S. Now I'm gonna use the monotonic stack template. So for each of the characters inside the S, I'm gonna use a while loop to check while stack and this character. So because it is a monotonic increasing stack, so I'm gonna use less. So if it is less than stack minus 1 for the character on top of the stack, yeah, if it is minus 1, and I also need to check the remain. So for this counter, if this remain stack minus 1, because I want to pop out the stack minus 1, so I have to check it. If it is more than 0, it means I can pop it out. So stack.pop, yeah. after that, so the stack should append this character C. Yeah. So finally, I need to draw the result. Yeah. But I didn't check if there can be repeated characters, because yeah, I checked the stack and this is less than, and yeah, maybe there's another character. Yeah, if I do it like this, this is wrong actually. I have to keep the unique for this for the stack. Yeah, if I submit it, let's check. Yeah, so for the first testing case, it is okay. As you can see, it is ABC. But for the second testing case, you can see that I just have ABC, but the result is like a CDB. Yeah. So if I were to put a character, yeah, I didn't use the counter, so the stack should append, and I needed to check the counter. So the remain, yeah, so the remain should be with this character should be -1. Yeah. Now let me check it. Yeah, it is still the same, but you're gonna see the difference. Yes. So I did it on purpose because I would you to see the result. Yeah. Yeah. This is something we're gonna check. This is the whole process I explained. If we do it like this, so for the first character, it is C and B. Because it is more than 1, we can put CB out, and then A, C, D, it is right, and then because C there's more than 1, so we're gonna pop C out, so it means ACDB. Yeah, if we get a ACDB, it is right, but we're gonna continue to check this C. Yeah, because we didn't check the uniqueness of the character. Yeah, so for the last character for this C, why we check? Oh, there is a stack, and this C is less than stack than B. Oh no, it is not, so I will not execute. But my stack will still append this number. It means I cannot append it. Yeah, I have to use if check to check if this character is not inside the stack. Yeah. Now let me do it from here. So if C not in stack, so this means for the last character, for this kind of character, if it is not inside the stack, I'm gonna execute it. Yeah, the whole process. Otherwise, I will not do it. Yeah, but for the remain, for the counter, I need still to -1, so I need to take this counter out of the if check. Yeah. So if it is this character not inside the stack, I'm gonna execute everything and to check. So in this case, I'm gonna avoid this C because C has already inside the stack. So I will not put it inside again because I want to keep the uniqueness. Yeah. So in this idea, I can put other characters. For example, there is a C, there may be another B. I don't need it. There's only a B left, another B left. I cannot do that. Yeah. Now, because there's no C and D. Yeah, I think this is gonna be a little bit difficult. Yeah, this is the only case we need to consider. So if this is C has already inside the stack, we cannot do that. If it is not inside the stack, we're gonna continue to do, because this character may be at maybe the last characters. Yeah. Now let me submit it. As you can see, it works, and let me submit it to check if it can pass all the testing cases. Yeah, but for this kind of a time complexity, let's just check what's the result. The time complexity will be O(n) square, because there's a for loop, and this is a C not inside the stack. This will also be O(n). For the while tag, it is okay because it is a monotonic stack, but the time complexity will be O(n) square. Yeah. Now let me just copy the same code to check if it works in this problem. Yeah, 1081. Yeah, because the length of the S is just 1000, maybe it works. Yeah, as you can see, it works. Now let me submit it. Yeah, as you can see, it works, and it's still pretty fast because this n is just 1000. Now let's check this problem. Yeah, as you can see, the result it also works, but it's not the fastest because the time complexity is O(n) squared. Actually, we can optimize this stack. Yeah, because if we check a character inside an array, it's gonna be O(n). But how can we make it O(1)? We can use a hash set. So let me use a visited set. So here we're gonna prepare an empty set. So here it is not inside the stack. It's gonna be not inside the visited. Yeah. And here stack.pop. Yeah, if we wanted to pop out something from the stack, so for the visited set, it should also be removed. Yeah, so the visited set should remove this stack.pop. Yeah, it means the two operations will be executed in one line of code. First of all, we're gonna pop out it inside the stack, and then we're gonna use this result to remove it from the visited set. Yeah, so here, if the stack wanted to append something, so for the visited set, just needed to add this character. Yeah, so in this way, we're gonna optimize the time complexity to O(n). Yeah, we still use some extra memory like visited set. We use the O(n) memory, but we've already used such memories, so it doesn't matter. But the time complexity will become O(n), and the space complexity will still be O(n). Yeah, and this visited set just needed to synchronize with the stack. It means if the stack wanted to put something inside, my visited set will also do something. If the stack wanted to remove something, pop out something, my visited set would also need to remove something out of the visited set. Yeah. Now let me submit it to check. Yeah, I think it is quite slow. Yeah, it is okay. As you can see, the speed is much faster. It is 91% because this is O(n). But sometimes if even you submit it, it is slower. But it doesn't matter because we still analyze the time complexity in big O, because it didn't depend on the machine. Because some machine is faster, some machine is slower. It doesn't matter. But while we are analyzing